guys, today we are going to learn all about measures of variability. By the end of today's lesson, you should be able to calculate measures of variability. In our last lesson, we looked at measures of center, and now we're going to look at measures of variability. With variability, you're looking to see how spread apart data is. Go ahead and get out your notes and be ready to learn. I just touched a little bit on what measures of variability are, but our first part of our notes says, a measure of variability is a way of describing how far spread out the data is. It can also be described as how much the data deviates from the center. And the word deviate just means to depart from the usual, or in this case, depart or be away from the center. Next, we're going to look at interquartile range. The interquartile range, sometimes abbreviated as IQR, is a measure of variability that splits the data into 4 equal-sized quartiles. It represents the middle 50% of the data. It can be found by 1. Ordering the data from least to greatest, 2. Finding the median, 3. Finding the median of the lower and upper quartile, and 4. Subtracting to find the IQR. These aren't different strategies, these are actually steps. You can notice here that you do need to remember a measure of center that you learned in the last lesson, and you need to remember what median is and how to find the median. That will be useful when you're finding interquartile range. At the bottom, it says a small IQR means that the data values are close to the median. Next, we're going to use our understanding of interquartile range to answer the questions below. Number 1 says the data set below represents the different costs of a camera at a local photography store. We have 28, 44, 108, 36, 59, 71, 66. And here it lists some of our steps out. First, we're going to write the data from least to greatest. As I'm ordering numbers from least to greatest, I like to cross them off in my data set to make sure that I'm including them all in my new order. I also like to just count to double check that I have the right amount of numbers from the data set when I have ordered them. Here there were 7, here I've got 7. So in order from least to greatest, they start at 28 and go to 108. Next question says, what is the minimum price? So minimum means the smallest, and so the least amount of price here is 28. We get that right here since it's ordered from least to greatest. Next, we want the maximum price, and the maximum price is 108, which is at the other end of our data set. Now that we've got them ordered from least to greatest, it should be a little bit easier to find the median price. To find the median, I start by crossing off a number from each side until you get to the middle. And in this case, since we had an odd amount of data points, 59 is the one that is in the middle. So the median price is 59. Now we get into some of the interquartile pieces, and we need to first find the median of the first half, which is called the first quartile. If you section off your data and look at the lower pieces, we've got 28, 36, and 44, because we stop at what our median was. So in our first half of the data, these are the numbers we have, and the median of that data is 36. You would then do the same thing for the second half of the data, or the third quartile. So not including the median, you would section off and look at the last 3 data points, which we have 66, 71, and 108. Then you would find the median or middle of those data points, which is 71. And finally, we're going to find the interquartile range. You might think back to what range is, and range is where you take your largest number and subtract your smaller number. In this case, we're only looking at the interquartile range. So we're going to take our first quartile, or our third quartile, and subtract our first quartile. So for this one, we're going to have 71 minus 36 to give us an interquartile range of 35. Let's go ahead and look at number 2. Number 2 says the following data represents the number of cars running the red light at the intersection of Main Street and Avenue A over a period of 2 weeks. And you can see the number of cars listed there. I want you to go ahead and pause and put those numbers in order from least to greatest. Now that they've ordered from least to greatest, you've got to make sure that you have the right amount of numbers so that you don't leave one out. That would mess up finding the median and the interquartile range. Here I counted 14 numbers in our data set, and I made sure that I had 14 numbers here, and I double checked myself. You can't rush through this, because if you rush through setting them up in order, then everything else is going to be wrong. Now I want you to pause and find the median of the data set. Let's play when you're ready to check. In this data set, there are 14 numbers, so there are actually 2 that end up in the middle, but we can't have 2 median numbers, so we have to take and find the mean of the 2 middle numbers. So in this case, 14 plus 12 divided by 2 is 13. So 13 is our median that is right in between 12 and 14. Now we're going to use that to find the interquartile range. In this case, I want to separate my lower half, and we can include that 12 this time, since 12 is not actually the median. And then the same thing on the other side, when you separate the upper half, you're going to include 14, since 14 is not the median. Now I want you to pause and find the first quartile, the median of the first half of the data. So the first half of data ranged from 6 to 12, and the median is 9. Now I want you to pause and find the third quartile, or the median of the second half. The third quartile, or the median of the second half, was 18. Finally, we need to find the interquartile range, where we find the difference between the third and the first quartile. So 18 minus 9 gives us an interquartile range of 9. Next, we're going to look at the mean absolute deviation, or commonly abbreviated MAD. The mean absolute deviation, MAD, measures the spread of the data in relation to the mean. Finding the MAD, the mean absolute deviation, is going to take a lot of prior knowledge. We need to remember how to find mean and how to find absolute value. We're also really looking here at deviation, or how far it strays away or is far away from the mean. So here are our steps. Mean absolute deviation can be found by calculating the mean of the data set, then finding the difference between each piece of data and the mean, then taking the absolute value of each deviation, and then taking the sum of the deviations and dividing by the number of pieces of data. A mean absolute deviation close to 0 means that the data values are close to the mean. So the closer to 0, the less it deviates. So now we're going to use our understanding of mean absolute deviation to answer the questions below. 1 says to calculate the mean of the data set. So looking at question 3, it says different students were asked the number of family members in their household. Use the data to complete the table. So the family number over here is not super important. The data comes right here. Number of family members. One family has 3, another has 2, another has 4, 2, 5, 6, 2. So we need to find the mean of that data first. Remember from yesterday's lesson, to find the mean, we add them all together and divide by how many there are. So this one, we don't need as much space to write them in order. When I add them all together, I get 24, and then there were 7 families, so I divide by 7. This gives me a mean of 3.42, and it keeps going, but we're just going to round to the nearest tenth, which is 3.4. Next, we need to figure out the difference between each piece of data and the mean. Remember, the difference means to subtract. So we're going to subtract each piece of data from the mean. So I know the box is kind of small, but here I've got 3.4, which is the mean, and I'm subtracting the data value. 3.4 minus 3 is 0.4. Again, the mean, 3.4, minus the data value of 2 is 1.4. Moving on, we would take our mean, 3.4, subtract the data value, which is 4. In some cases, really, if you are subtracting, you're going to get a negative number. But remember, it said something about the absolute value, so we're not super worried about the negatives right now. In this case, 3.4 minus 4 is negative 0.6. Moving on, we've got another 3.4 minus 2 is 1.4. 3.4 minus 5 is 1.6. 3.4 minus 6 is 2.6. Really, those are negative, but we're going to find the absolute value later. And then we've got 3.4 minus 2, which is 1.4. In the next column, we're finding the absolute deviation from the mean. So this is where we find or take the absolute value of each deviation. So absolute value is distance from 0, and that's always positive. It doesn't matter if you're going to the right or to the left, distance is always positive. So I'm just going to take all of these differences and make sure that they are positive. So 0.4, 1.4, 0.6, 1.4, 1.6, 2.6, and 1.4. And then finally, step 4 says the sum of the deviations and then divide by the number of pieces of data. Or really, we're finding the mean of the absolute deviation. When I add together all the absolute deviations from the mean, I get 9.4, and there are still 7 families. So when I take 9.4 divided by 7, I get 1.3. Question A underneath that says, what is the mean absolute deviation? And that's what we just found here. We found the mean of the absolute deviations. So our mean absolute deviation is 1.3. Question B says, explain what this means for the size of the families surveyed. So what this means is the average number of family members was 3.4. Remember, average is mean. And that most family members only deviated or strayed away from that by 1.3. Most members in this data range from 2 to 5 members in each family. We're going to look at our last question. It says, in a science class, an experiment required counting the number of M&Ms in a small package. Use the data to complete the table. So here we've got our number of green M&Ms listed out that each person counted. First, we need to follow our steps and find the mean. I want you to go ahead and pause the video and let me know what is the mean of this data. When I add together all of the data, I get 68, and there are 10 pieces of data, so 68 divided by 10 is 68. And I've just got that written up here because this table isn't set up as nicely with the mean spots as the other table was. Next, we need to find the deviation from the mean. Remember, we're taking the difference of the mean and the data point to find the deviation. So my mean was 6.8, and my first data point was 7. So 6.8 minus 7 is 0.2. Go ahead and find the deviation from the mean for 9. So 6.8 minus 9 is 2.2. Moving on, 6.8 minus 4, 6.8 minus 12, 6.8 minus 3. Go through the chart. You might even go ahead and, like I do, I just go ahead and make them the absolute value because I know that the negatives aren't really important for finding the mean absolute deviation. So I even kind of like to show my work here, 6.8 minus 7, and then write just my positive answer over here. So even though 6.8 minus 7 is technically negative 0.2 in my calculator, I know the negative really doesn't matter because I want the absolute value anyway. So in my mind, I've kind of already gotten rid of that negative. So I just can start writing my deviations in absolute value form in this final column. Go ahead and pause and find the deviations for the remaining pieces of data. Now that I have all of my deviations, my absolute deviations from the mean, now I need to take the sum of those deviations and divide by the number of pieces of data. So I need to find the mean of the deviation. So I had to pause the video and find the mean absolute deviation. Press play when you're ready to check. The mean absolute deviation is 3.04. After I add all of these together and then divide by 10, I get 3.04, and that is the mean absolute deviation. The final question says, does the MAD represent a large or small amount of variability, and why? Thinking at the beginning, it told us that A mean absolute deviation close to 0 means that the data values are close to the mean. So in our last example, our mean absolute deviation was 1.3. So when I look at this, I see that 1.3 is closer to 0 than 3.04 is. Again, think on a number line. 3 is 2 spaces over. So I want you to go ahead and pause and answer this question. Does the mean absolute deviation represent a large or small amount of variability, and why? So I would say that this represents a large amount of variability since 3 is a little bit further from 0. Also, if you consider the amount of M&Ms in a package, these packages range from only having 2 greens to 11 greens, and that's pretty spread out data. Whereas in our last example, it only ranged between 2 and 5. So between 2 and 5 is a lot closer than between 2 and 11. Now that you've made it to the end of the video, let me know what color Skittle is your favorite. Today we learned all about measures of variability. By the end of this lesson, you should now be able to calculate measures of variability. In this lesson, we talked about finding the interquartile range, where we needed to find the median and then find the lower and upper quartiles. And then we looked at finding the mean absolute deviation, where we needed to use the mean and figure out how far each data point deviated from the mean. Let me know if you have any questions. Bye, guys.